always the hardest because it's most like the SOL. So basically, we've been doing this for a while. We want to underline the P. Animal is a fish. Then it lives in water. I need a new color and a new variable because that's different clause, different information. So I've got P, arrow Q. That's my conditional statement. So then when I go to the next sentence, this is a simple sentence. It's not a compound sentence. It's just one simple clause. Shrimp live in water. That most closely matches the live in water of that Q statement. So I write Q. This can't be syllogism because it's only a simple sentence there. Then I go to the next thing. Shrimp are fish. The are fish is the same as is a fish. So that's my P. This is the converse. I've just changed the order. PQ turns into QP. Converse is not valid. Converse is not valid. This is detachment. Detachment, something close to that anyway. Detachment, and it's not good detachment, so it's not valid because it's the converse, right? Questions on that? Okie dokie. How about number 2? If I want a counter example, what do I call that? A counter conclusion. So I want to keep the hypothesis. This part is good. So whatever I have has to be squared and equal 100, but I can't use positive 10. The only option is negative 10. B is not a counter conclusion. It's not a counter example. 100 is not a counter example because 100 squared is 10,000. But negative 10 squared, negative 10 times negative 10 equals positive 100. That makes this true. So that's my answer. Okay. Getting better and better at those. So just stinking. Here, I want you to graph these and be really careful. I'm going to go left 8 and down 4. So left 8 and down 4 is going to take me into quadrant 3. Remember, this is 1, this is 2, this is 3, this is 4. They're labeled like a C. Okay, that's counterclockwise. So I've got negative 8, negative 4, and then I'm going to go right 2 and up 6. So right 2 and up 6. My midpoint is going to be somewhere in here, I think, right? Midpoint between those two endpoints. So just want to make sure I've read it correctly. Plot the original points and then answer, and then put your answer in the yellow box. So I'm going to find the average. X plus X divided by 2, and Y plus Y divided by 2. That's a 2, by the way, not a 3. So negative 8 minus 2 divided by 2 is going to be negative 10 divided by 2, which, oh, wait, nope, that's not right. That's a plus 2, because that's a plus 2. So that's 6 and a negative 3. And then your y's, negative 4 and 6, negative 4 plus 6 divided by 2. Negative 4 plus 6 is positive 2. 2 divided by 2 is positive 1. About 70% of people got that right answer. If you didn't get that right answer, you probably did something weird with the signs, like I was about to with the adding and the subtracting. So always go back and double check what you're doing. Okay. Still same points, negative 8, negative 4, and 2, 6, 2, 6. This time I want to determine distance. So distance is the face. X minus X squared plus Y minus Y squared. Substitute all those guys in. So negative 8 minus 2 squared plus negative 4 minus 6 squared. Negative 8 minus 2 more is negative 10. Please make sure you put that negative 10 in parentheses. It's super important. Just like over here, that negative 10 needs to be in parentheses. So that's going to be 100 plus 100, or the square root of 200. Square root of 200 is the same as the square root of 2 times the square root of 100. So that's going to be 10 times the square root of 2. Hopefully you remember that from algebra, right? I know I kind of went fast. The other way to do this, if you like to plot points, is start at your leftmost point and go to your rightmost point. And it doesn't matter if you go up and right or right and up. That's going to make a square. Or if you just do one of them, it'll make a right triangle. That right triangle, you can use Pythagorean theorem. A squared plus B squared equals C squared. That way you jump straight to this part and you don't have any sign errors. Does that make sense, everybody? So my answer is A, 10 times the square root of 2. If you're not sure about all of this nonsense with the radicals, find the decimal, okay? Square root of 200, if I put that in the calculator, gives me 14.1. Then I just go to all of my answer choices and figure out which one equals 14.1. Yes? No? Maybe so? Are we awake on this wonderful Thursday morning? Okay. You guys tell me whether I did this correctly. Can I put dots for alternate interior angles here and here? Why not?
That's exterior.
That is exterior. So these guys need to go here. I'm going to erase these and try again. How about here and here? Does that work? Yes, no, maybe so? Yes, excellent. All right, so I've got interior, I've got exterior. What about corresponding? Can I do that and that? Are those corresponding?
No.
What are those? They're not corresponding. Okay.
Same side.
They are. They're same side exterior, which really isn't a thing that we talk about. Those corresponding? Did I improve it?
Yes.
Yes. Okay. So what if I do same side interior? Can I do that?
No.
What is that? Which one of the remaining choices is that? Are those vertical or linear?
Linear.
Those are linear, absolutely. So if I remove that guy and I put in one here, does that make it better? Are those same side interior?
Yeah.
Okay. And then vertical, can I do vertical like this? Yes? Okay. Alternate interior angles. When I set up my equation, are they going to equal each other or equal 180? Alternate interior. Equal each other or equal 180? Are they both acute, both obtuse, or one of each? These two orange angles that kind of make a Z. You kind of see that Z?
Are they equivalent?
They are equivalent. These guys are going to be equal. Anytime you can make that Z and you have one angle in each of the crooks, or it kind of looks like a stretched out N maybe, that's going to be equal, okay? What if I have, this kind of looks like an upside down F. Are those equal or are those supplementary? They are equal, absolutely. What about this one that looks like a U? Are those equal to each other or equal to 180?
Equal to each other.
Those are going to be the 180, same side supplementary. Okay, same side supplementary. You can remember all the S's go together. What about alternate exterior angles? Are those going to be equal to each other or equal to 180? If I spin those around on top of each other, do they land on top of each other? Are they congruent?
Which angles are we looking at again?
The alternate exterior angles, these guys right here.
They'll be congruent.
They will be congruent. What about the linear pair? These guys down here, do they equal each other or equal 180? They equal 180. They make that straight line, so they're going to add up to 180 degrees. Notice that these are the only two that add up to 180. And then you've got these two vertical angles that are kind of kissing each other. Those are going to be equal, okay? Guys, these aren't going to go away. They just get more complicated, to be honest. So we're going to see these here. We're going to see these in triangles. We're going to see them in quadrilaterals. We're going to see them in circles even. We've got to get these under control and figure out which ones are equal and which ones are supplementary, okay? If you need help with that, come to office hours today. I promise we can talk through it, okay? How about here? I know we haven't spent nearly as much time as we should on constructions, but can we use our good vocabulary to figure out, let's see if I number these. Oops, I need a color. We'll do 1, 2, 3, 4, 5, and 6. What number is the congruent line segment? Which of those is the congruent line segment? Anybody? Number 1, 2, 3, 4, 5, or 6? Which one shows two congruent line segments? Number 1, yeah, absolutely. Which one shows the angle bisector? You've got an angle and it's sliced in half somehow. 2, 3, 4, 5, or 6. We're down to a 20% chance. 6, love it. So we're just kind of looking for the easy ones to identify. How about congruent angle? Which one has a pair of congruent angles? Hint, they're not right. They're acute. It is 2 for sure. It's kind of a stinky question because when I make perpendicular lines, I automatically make 4 right angles, which are congruent. It's not really the intent of this construction. So now I've got 3 perpendicular choices. How are they different? I've got one that has a not on the original line, one that says on the original line, and one that says bisector. Any ideas on how we can identify which one is which? A point on the line, a point not on the original line, and then a bisected line. Give you a hint, the original line is always the horizontal one. I think the bisector is usually easiest for me. Which one is bisected? Does look like it's 4. If I make 4 a little more clear, those are arrows. And those are arrows. And those are endpoints. Does that help at all? And there is an X up here. So those are compass marks. You've drawn those. And you've drawn these. And then you've drawn these. Which one has been bisected? Can I bisect a line that goes on and on forever? Or can I bisect a line segment that has 2 endpoints? I'm going to help you out. This one is the bisector. Awesome. Line segment. I'm sorry, I can't see the chats. I can see that there are 2 chats. I just can't see what they are. So thank you. This guy has a line segment, so I can bisect it. Okay. This one, we've started on this point up here. So this is from a point not on a line. And this one, we started from this point. This is a point on the line. And these 2, 4 and 5, are the most confusing. Those make me mad. All the other ones, though, I feel like we can get because of vocabulary. Okay. Questions on that warm-up? We spent a good long time on it. What I'd like for you to do is meet me in this Desmos activity. Okay, so everybody needs to open this. Only about half the class opened it last night. Several people sent me messages that were like, we don't like this. We haven't done this. This doesn't make any sense, right? So we didn't get to the puzzles yesterday that would have helped you with this. Basically, if you open up this Desmos activity, which hopefully everyone has now, because I will double check. Let me see if I can open this chat and see what people are saying. I don't know how to make this chat come up. So basically, you're going to follow the directions. It says click on an angle to reveal its measure. So I'm going to click on this obtuse angle. Which other angle is going to be 138? The angle across from it. So I can put in 138. The whole idea with these puzzles is to click reveal the least number of times necessary. Is there anything I can do in my calculator to figure out what those acute angles on the sides are? What math can I do?
Minus 138.
Absolutely. So if I do 180 minus 138, I'm going to get something like 42. Is that what I'm going to get? So then I can type in 42 right here and right here, because those are vertical, right? It's going to check your work, and it's got this cool little doot, 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 and I'll give you little check marks. And if you didn't get it right for some reason, it'll let you go back and redo it. So basically, this whole assignment was exploring all of the angle measures that we already know and that we just talked about. So this time I'm going to click on the acute angle. Which other angles are going to be 45 degrees? The ones up here. So I've got alternate interior angles. So this one is 45. And I've got corresponding angles. So this one is 45. How can I calculate this big guy down here? What math can I do? If they make a straight line, they should add up to 180. So if I do 180 minus 145, do I get 135? Yes, check my work. So hopefully as I'm doing this, you're doing yours. I don't know, do you guys have the same numbers as I do, or are they different? They're different, okay, but it's the same pattern, right? Oh, you have the exact same ones? Okay. So which angle, I've got 5 choices, should we start with here? Lower right it is. So if I start with the lower right, we kind of talked briefly about this Z pattern. If I know that this angle inside the Z is 60, which other angle is 60? Yeah, this top right. So they're in the crook of the Z. Those are alternate interior angles. So this guy's going to be 60. Can I calculate anything else? Or do I need to reveal something else? I need to reveal something else. Do we want to do the acute angle at the top of the triangle, or the acute angle at the bottom? We just got to choose one. There's no right or wrong answer. My cursor is here, so let's reveal this one. Maybe. Oh, reveal another. So if I know this guy at the bottom is 38, is there another Z I can make? Another alternate interior angle? Beautiful, for sure. The one at the top is 38. And then if I know these two inside the triangle are 38 and 60, how do I find this top angle in the triangle? Yeah, absolutely. So I'm going to get 180 again, and in my calculator, subtract 38, and then subtract 60. So if I reach for my calculator, which hopefully everyone is doing right now, don't make Miss Doherty do all the work today. Minus 60 and minus 38, I get 82, question mark. Check my work. I know you guys love the sound effects. That's all there is to it, guys. So we get angle measurements in all kinds of different ways, and there are a ridiculous number of ways for us to ask these questions, be asked these questions, see these questions, think about these things, right? it's definitely setting you up to go to Algebra 2 trig and math analysis and calculus beyond that. So we just kind of got to be able to see how all of these things can be broken apart and then put back together again. That's kind of what we're doing. So if we imagine that the lines stay parallel, but could drag points A, B, and C to make any triangle in the world, click two or more angles that you think would always be congruent no matter what. So if I know these lines are parallel, I know I always have a Z on that side, and I know I always have a Z on this side. So which two angles are always going to be congruent? There are two choices. You can either choose the two pink angles that are inside the alternate interior relationship or the two orange angles. And either one of them is going to be true. Okay? And then you can type something there. We'll share it with the class. Hopefully you have typed something better. I've got corresponding, I've got equilateral, I've got corresponding, I've got all kinds of good stuff in there. Okay? Test your claim. So if I drag this C, do those alternate interior angles stay the same? No matter how I make that triangle? Woo! Isn't that cool? I know you're excited. So which angles here should be the same?
X and Y.
X and Y? Are they all going to be the same? What if I draw that Z in there again? So I trace a parallel line, come to an angle, do the transversal, and then do a parallel line. So alternate interior angles are the ones I'm looking for. We could also do the Z the other direction, and we could do a parallel line, a transversal, and a parallel line. Can I change the color of my dot? I don't know if I can. Oh, I can change the color of my dot. That's so exciting. So Y and this angle down here are always going to be the same. Notice that it's one inside the triangle and one outside the triangle. So the two purple dots are equal and the two orange dots are always going to equal because they're alternate interior angles. Okay. I don't know why Equatio all of a sudden came up. I don't want you here. What angle can I click on here? We just have to choose one.
The 91.
The 91, the top of the 90 or the bottom of the 90?
The bottom.
Okay, so I click on the bottom, that's 34 degrees. Does that tell me anything? What should these two angles add up to be? 90, so if those should add up to 90, I can do 90 minus 34, and what's 90 minus 34? 56, perfect. Does that help me find anything, or do I need to reveal another angle? I think I have to reveal one more angle. So what other angle do you want to reveal? 1, 2, 3, or 4? 1, 2, 3, or 4? Anybody? Let's go for the smallest one, since I'm right here. So now if I know that this triangle has a 34 and a 41, how do I figure out that top angle?
Wouldn't you do 34 plus 41 and then subtract 4?
Absolutely. So 34 plus 41 is 75, and then I subtract that from 180 and I get 105. So I'm going to go here and do 105. And then what can I find from there? I went from the right angle to the triangle. Do I have a straight line here? What should those two angles add up to be? 180. So what's 180 minus 105? Does that take me back to 75? Notice that this is our exterior angle sum. Angle 1 equals angle 2 plus angle 3. right? So this was a crazy way to give you a review of everything that we've learned. And if we had had just a little bit more time to practice yesterday, it would have been better. So what about this triangle? How do I find the missing angle of that triangle? Subtract the 2 from 180. So I'm going to start with 180, subtract 75, and then subtract 56. Notice that there's two methods here. Here I started with the whole thing, the 180, and subtracted the two smaller numbers. And over here in orange, we added those two angles and then subtracted them from 180. It doesn't matter if you subtract and then subtract, or if you add and then subtract the sum. It's going to work both ways, and different people like to do it differently. So let's reach for the calculator. 180 minus 75 minus 56 equals, drum roll please, and we have a 49. Check my work. Does it make a little bit more sense now that there was an explanation? Hopefully. So if we leave that, I know I'm jumping around like crazy today and haven't given you an ounce of practice time for yourselves. This is what we were supposed to start with yesterday, right? So those would add up to 90. So I would do 90 minus 53, right? These would add up to 180. It's basically what we just did. So I would do 180 minus 74. And then I've got two triangles. I've got this pink triangle that's going to add up to 180. And I've got this green triangle that's going to add up to 180. Okay. You're going to get some puzzles like this on the test. And you just have to think them through. You don't have to go all in this right order, but you can if you want. So how would I find angle 1? What would be the process? What do I know about angle 1? It's next to that 88. Absolutely. So what should those two add up to? 180. Nice. You can extend these parallel lines. So I've extended them with dots. I give you 100% permission to extend any parallel line as far as you want it to go. If you make those weird little Z's again, I've got a parallel line and a transversal and a parallel line. That's how you make them. What other angle is 81? What other angle is in that Z? What's alternate interior to the 81? Got an 81 here. And what else is in that? What else is in a yellow corner? The 5, absolutely. So 81 and 5 are going to be congruent. They're going to equal each other. That's what we talked about in the warm-up. So yeah, it all links together. And you can't, in geometry, you can't take a test and dump it and move on, and take a test and dump it and move on. It is all going to build. You've got to know the stuff from the beginning in order to move forward. Okay. And once we get that, notice I have not gone to angle 2. I don't know enough about that triangle, right? I've got this blue triangle over here, but all I know is angle 1. So there's nothing I can do. But over here, in this triangle, if we find angle 5 is 81, then can I find angle 4? Which should those angles equal? Every triangle adds up to 180. So I can find angle 4, and then these 3 angles make a straight line, so they're also going to add up to 180. Guys, this is the way to attack these puzzles. Okay? You do not need to go in order. You can find whatever angle makes you happy first, whatever you see first. I tend to find linear pairs first and vertical angles second, and then move on to all the difficult stuff. I look for as many triangles as I can because I know triangles add up to 180. Let's look at one more. Where would you start here? We'll actually solve this one. What would be the first angle you tried to find? Don't everybody talk at once. I would find angle 2. We could definitely find angle 1. So angle 2 is 61. How would we find angle 1? Because I heard like 2 and 1 at the very same time. What math would I do for angle 1?
Subtract the 61 and 60 from 1.
So simultaneously, I heard add those two to get 129 and then subtract it from 180. And I heard take 180, subtract 68, and subtract 61. Those are the exact same thing. It's just different order of operations. So what answer do I get when I do that? Something that ends in a 1. 151. Did we subtract 51? We got to remember to subtract that 129. And then if I know angle 2 is 61 and I know I have this right angle right here, what math do I do for angle 3? Trying to save room here. Is that 29? Take a minute with this one and you find 4 angles. I don't care which 4 angles you find, just find 4 of them. So on a piece of paper, on whatever you need to use, find 4 angle measures. Seven is in this obtuse angle. That's a really good question. 7 is here. Boom. So everybody's finding at least 4 angles. Yeah, of course. All right, if you know one, call it out because I can't see my chat box right now. Where'd you start? What was the first one? Okay. I think there is a 29. Angle 7 looks really obtuse though, so I'm not sure it's angle 7, but I think there is a 29. 5. Angle 5 makes a straight line with 115. So what should they add up to? 6. That they should add up to 180, so the answer is 65 for sure. What other angle do we know? 4. What's 4? 115. Those are vertical. Can we finish out that circle? If I know 115, 115, 65, what's angle 2? Also 65. Okay. What's another angle we could find? 1. So that makes a triangle. So what's angle 1? Don't wait for somebody else to do the work. If you know 80 and 65, what's angle 1? I think so. Now we get to something that I haven't talked to you about yet. This guy over here is a quadrilateral. It's got 4 sides, 1, 2, 3, and 4. Quadrilaterals add up to 360 degrees. So if I tell you that those add up to 360 degrees and you know 65 and you know 61 and you know 90, what's that angle 7 that we talked about earlier? So same process, add up the 3 you know and subtract it from 360, or start with 360 and subtract out the 3 that you know. 144, loving it. So if we know 144 and we know 6 and 7 make a straight line, what should 6 plus 7 equal? 180, good guess. So how do I find angle 6? Calculators are working. 36, that's what I got. And then if we know angle 4 is 115 and angle 6 is 36, how do we find angle 3?
29.
That is our 29 that we started with. Awesome. Okay. So I think they're kind of fun once you get into them. They're just like little puzzles to think through, right? All right, so that got us caught up from yesterday, got us caught up with the homework from yesterday. Now it's time to start our legitimate lesson. So our legitimate lesson is day 3. I cannot believe how fast we are asking you guys to move, by the way. So if you feel like I'm moving at lightning speed, it is because I am, and I apologize for that. But man, I don't know how else to do this 4x4 thing in 4 short days. So notice that there is a quiz and a homework 3 tonight. Okay, make sure that you get those done. Please make sure that you get those done. Grades are closing next week for second quarter, and you don't want to move into the second semester with stuff not right. So I am going to make this into a pear deck, and I'll send you the link. Oh, that's not what I wanted. Maybe I closed the wrong one. I'm going all over the place. I had this open earlier. This is the first 2 pages of your digital notebook, or this is page 6 of your digital notebook. So you can find that in your digital notebook, but I'm going to open a pear deck so you have it here too. And then you can go back to your digital notebook if you want. And I think since I can't see my chat, oh, my chat opened up. Tag on it. It's being so slow today. This is your brain break. Okay, there's your pear deck. I am going to share my screen and talk through the first couple of slides. So you can do it in your pear deck if you want. Okay, can everybody open the pear deck? Everybody see it? It's a mystery why sometimes I can see the chat and sometimes I can't. Okay. So basically we're talking about isosceles and equilateral triangles for the rest of the class. Okay, and this will be what your homework is mostly on. We've got isosceles triangles, and you know what they are. They've got two angles that are the same, we call those base angles. And we've talked about if we kind of do lines straight through the center of the triangle, those two legs have to be the same as well. So if I know that JK and KL are congruent, and I know that L is 68, what's J? Also 68, absolutely. And because I know triangle sum, I know that if these two angles at the bottom, these two base angles are 68, what's the apex angle, the vertex angle, the one at the top? What's angle K? How could I find that? Let your thumbs do the work. 180 minus 68 equals 44. Okay, that's just triangle sum. If I know that X is 77 and Z is 77, then what leg is also 12? Is the Y and the Z, absolutely. That guy is also 12. And then how do I find that vertex angle, that apex angle? If I know 72 or 77 and 77, how do I find that missing one? 77 plus 77, and then 180 minus that answer. And what do I get for angle Y? 26. Say it with confidence. 26. So my side is 12 centimeters and my angle is 26 degrees. Make sure you know that you're talking about angles and sides. It seems super basic, but at some point in the next week, I promise every single one of you, or let's not say every single one, 80% are going to mix up sides and angles at some point. And then you're going to go, oh, I knew that was an angle. So that's isosceles. Two base angles are the same, and that means if I go straight through the center of the circle, the two legs opposite are the same, okay? So two legs and two base angles. If I move into equilateral, we've talked about this. Equilateral triangles mean that all of the angles are exactly the same, and all of the sides are also exactly the same. So if I know angle A and angle B are 60, what's angle C? Do I even need to do any math?
No.
No, it's 60. Boom. 180 divided by 3 is 60. If I know that AB is 9 feet, what's BC? 9 feet. And AC is also 9 feet. Boom. All my sides are exactly the same, and all my angles are the same too. So what do I know about the JKL triangle? All angles are 60 and all sides are 24. Okay. So you know it's going to get harder. So boom, slide 3 is harder. How on earth do I figure out X if I know 74 and X plus 12? What equation can I set up?
Could you do X plus 12 plus 74 equals 180?
If I knew this angle here, let's say that's Y, I could 100% do that. I could add up all three angles and have them equal 180. The problem is I don't know this one. So I love that shot in the dark. And if I knew Y, we could 100% do that. Is there another thing I can do to just relate the X plus 12 and the 74?
So that they equal each other?
They would 100% equal each other. Those are the base angles, okay? This angle here and this angle here are going to be congruent. So then you just solve that, okay? I'm just going to click through these. Same thing here. These two angles are going to equal each other because they're the base angles, right? So then this side and this side are going to equal each other. We just set them up and solve them, okay? I'm going to stop sharing and I want you to work on your pear deck. Everybody should have, boom, their pear deck open. The link is in the chat. And I want you to start working if you haven't already. Set up those equations. When you get stuck, shout it out, and we'll meet on that page and see.
I have a question. I will we do slide 10.
Slide 10. Let's go look. Oh, slide 10 is a good one. All right, if you're not on slide 10, come to slide 10 and meet me here. So we've got a red isosceles triangle and a blue equilateral triangle. We already talked about in puzzles like this, we don't have to start with angle 1. So what are the easiest angles to start with? There's no right or wrong answer, you just choose. What's easiest for you? Anybody? The equilateral, for sure, okay. So what do I know about equilateral triangles? They're all? They all have the same size. They're all equal. So what's the answer to 4, 5, and 6? Oh, yeah, I didn't click share. Thanks for keeping me straight. So 4, 5, and 6, they're all going to be the same. And what number do I put there? 60. Boom, boom, boom. Already 1/3 done. That makes me so happy. If I know that 4 and 6 are 60, what are 8 and 3? What are those going to add up to? 3 plus 4 equal
120.
They're going to equal 180, so they're each 120 for sure. So angle 3 is 120, and angle 8 is 120. Again, I'm not going in order on the chart. I'm just going for what's easiest to me. 2 and 7, I'm not sure I know how to get yet, but I think maybe there's a good plan for A and C. How are these expressions related? If that's an isosceles triangle.
Because you can do 4x plus 2, 3, then 9x minus 3, 7. You'll equal it to 180.
Can I equal it to 180? I can do that if I know all 3 angles. If I knew B, I could do that. Do I know B? I like where your brain's at. It's an isosceles triangle. What do I know about isosceles triangles? 2 sides are equal. So this side and this side are equal. So what do I know about the pink angles? That they're also equal. So boom, I can do that. Normally I subtract my smaller variable. So I'm going to subtract 4x. So I get 5x. If I move my x's to the right, I move my numbers to the left. So what's x equal? 10. So for number 1, do I put 10 or do I have to do something different? Did I just find the angle of 1 or did I find x? I found x. So I've got to stick a 10 in here. This is where life gets complicated. So I've got to do 4 times 10 plus 3, which is 43. So this guy's 43. If I stick a 10 in here, it should get the same thing. If you trust that your math is good on the first problem, you don't really have to do the second problem. 9 times 10 is 90. 90 minus 47 is, in fact, 43. Now that we've got all of that, these triangles over on the wings should add up to what? What should angle 7 plus angle 8 plus angle 9 equal? 180. So 7 plus 8 plus 9 should equal 180 because that's that yellow triangle over on the right side. So what math can I do to find angle 7? Subtract 180 minus 120 minus 43. 7 is going to be a very tiny little sliver. And we can do the exact same thing on the right side over here. Angle 2 and angle 3 and angle 1 should add up to 180. So angle 2 and angle 7 should both be the same number. Does that kind of make sense how I approached it? Maybe? Okay, keep working. We got about 10 more minutes of class. When you are finished, you can go ahead and go on to the quiz and the homework. If you have questions on either of those, please come to office hours today. I get bored when I'm sitting here by myself, so come visit me. Of course. Tomorrow is going to be kind of a ridiculous Friday, so come ready tomorrow. You guys are killing this. I'm so proud. I think we might need to look at slide 8. So slide 8. I'm going to share my screen with you again. Go to your slide 8. Let's chat about this one. So here we're given degrees. Okay. So I need you to notice those little degree symbols right there. We're told that these two sides are the same. If I go through the middle of the triangle, then these two angles are the same. That means this angle at the upper right is also 8x minus 23. So here, because I've got angles, I'm going to add up all of those angles. So angle 1 plus angle 2 plus angle 3 is going to equal 180. 8x minus 23 plus 8x minus 23 plus 34 equals 180. If you've got sides, you can set them equal to each other. If you've got two angles and they're congruent, you can set them equal to each other. But here, the 34 is your vertex angle, and these two angles are your base angles. So I've got to do 8x minus 23 twice. So 16x minus 46 plus 34 equals 180. And then you got to combine like terms and solve from there. Okay, so be careful on questions like that. You got to double check and make sure you know which ones are the base angles and which one's the vertex angle. Make sure you're also answering the question being asked. If you do all kinds of great work and you get a correct answer, but you don't give the correct answer, it's going to be marked wrong. So just double check. If I ask you for an angle, give me an angle. If I ask you for a variable, a variable, give me a variable.
When it says what's the measure of the smallest angle, is it asking like the formula that we do, like
Which question are you looking at?
The homework. I mean the quiz.
The quiz. Schoology's being slow. I'm trying to get to it. Which question, Nisha?
Number 2.
So for the benefit of the class, I'm going to share my screen again. So question number 2, what is the measure of the smallest angle? So you need to solve for x first. So what equation would you use to solve for x?
Well, 9x plus 65 plus 70 equals 180.
So you're going to find x equals whatever it is, and you don't need to say it out loud. Once you find x equals, you need to substitute it back in here because you don't know if this is going to be the smallest angle or if this is going to be the smallest angle. So you've got to find that third angle measure in a number. and then tell me which one is the smallest.
65.
Okay, so then you type that in.
Okay, thank you.
Yep. And I think the bell is going to ring here in about 1 minute. So hopefully we've done enough practice that you guys understand and it makes sense. Again, if it doesn't, come to office hours. I'll be here from 2 to 3. Okay.
Wait, so when I type in the smallest angle, do I put 9 next? Or do I put whatever I got for it?
Whatever the angle measure is in degrees. Whichever angle is smallest.
Okay, thank you.
Mm-hmm. I'm sorry, I didn't hear you, Michael, because the bell.
So what day are office hours again?
Mondays and Thursdays. And if you go into Schoology at the very top, it should show you. I'll share my screen. Yeah, so office hours are right here, Monday and Thursday from 2 to 3. And once more people are back in the building, if you need me to extend those hours, because you're in the building and you're trying to get home and you're not home until 3 o'clock, let me know and I can extend and change those office hours. So this one, these two angles are the same. So your equation is going to be 8x minus 23 plus 8x minus 23 plus 34 equals 180.
Okay.
Yeah, I think you were in the restroom when we talked about that one. I'm glad you asked. Gabe, Alexis, did you guys have questions?